Hey guys, it's Miss Phelps. Today we're doing lesson 4.1, Identifying Functions. Alright, today's learning target and what you should be able to say by the end of this lesson is I can define what a function is. So that's what we're going to learn today. What is a function? Functions. A function is a relation from a set of inputs to a set of outputs where each input is related to exactly one output. So basically, each input needs to have exactly one output. So right here we can see we've got our input, it's going to our output, check. That's good. That's a function. In this example right here, our input is going to two different outputs. So in this case, it is not a function. Okay, our input can only have one output. Functions can be described in many ways. We can have an equation, we can have a table, we can just have a bunch of words, a graph, or a set of ordered pairs. There are lots of ways to describe a function. Alright, determine whether each relation represents a function. Explain your reasoning. So going back to right here, our input, which is x, can only have one output. So each x can only go to one y. So right here, we've got our set of x's and our set of y's. So if we put this on a graph, we've got 0, let's just call this 8 right here. 0, 8, 1, 8, 2, 8, 3, 8, and so on and so forth. So we're going to get a line that looks like this. Because we have an x and it is 0 and it only goes to 8, this is okay. We have 1 and it only goes to 8. So yes, this is a function here. So the answer for A is yes, this is a function. On this one here, we have 0, or sorry, this is our input right here, x. Input is x, always, always. So we've got over, let's call this 8 right here. 8, 0. Then we've got 8, 1, 8, 2, 8, 3, so on and so forth. So we have a line that's going to look like this. Right here, going back to this problem, our slope is a horizontal line, so our slope is going to be 0. Remember, if we have a slope that looks like this, it is undefined. And if we have a line that is undefined, that means it cannot be a function. So no, this is not a function because we have our input 8 and it's going to 0, it's going to 1, it's going to 2, it's going to all these different numbers, and so we can't have our input going to more than one number. Our input needs to only have one output. Alright, let's take a look at C. Is this a function, yes or no? We have 1 going to only 8. We have 2 going to only 9. We have 3 going to 10, and 3 is going to 11. So because of this 3 having two outputs, it is not a function. So no. Another way to determine if it is a function or not is by using what is called the vertical line test. Pretend that says vertical. Okay, the vertical line test basically says if I draw a straight line, a straight vertical line down here, and it only passes through one point, then this graph is a function. So we need to see if it passes the vertical line test. So if I draw a line right here, yes, It only passes through one point. If I do it right here, we're still good. If I do it right here, I've just passed through 2 points right here. So because of this, it is not a function because I passed through 2 points, which means that our x right here, that is 7, this point is 7, 5, and this point is 7, 8. So because our 7 is going to 2 different numbers, this is not a function. Also right here we have the same case. We have 5, 4, and 5, 5. So our x that is 5 is going to 4 and 5. So because of these 2 instances, this is not a function. Function notation. So this is a new notation that we are learning, and we're going to write f of x equals, and then we can just write whatever we want on this side. I'm going to write 3x plus 2. So basically this f of x is replacing what we would have as y. So y equals 3x plus 2. The reason that we use f of x is so that we can put in a number to replace x. So, for example, if we had f of 2, we can see that instead of writing x, we wrote 2. So everywhere where we would normally write x in this equation, we're going to write a 2 instead. So right here we've got f of 2 equals 3 times 2 plus 6. Or sorry, 3 times 2 plus 2. I was doing the math already in my head. 3 times 2 is 6 plus 2, so this simplifies to 8. So this is function notation when we have f of x replacing our y. Alright, determine whether each relation represents a function. Explain your reasoning. Remember, if x repeats, it is not a function, okay? It's not a function if f repeats. So right here, I'm just going to underline all of my x's. So we've got -2, -1, 0, 1, and 2. Because these are all different x's, this is a function. Right here, I'm going to underline my x's, and it looks like I already have repeating right here, -1 and -1. Because I have -1 going to 0 and -1 goes to 1, this is a repeat of my input, and it has 2 different outputs. So no, this is not a function. Each radio frequency, which we're going to call x, so we know that this is our input. So each radio frequency in a listening area has exactly 1 radio station. So each x goes to exactly 1 y. That's perfect. That's exactly what we want. So yes, that is a function. The same television station, so we've got this television station right here, we'll call it T, can be found on more than one station. So it's on station 1, or sorry, more than one channel. It's on channel 1, 2, and 3. So we've got our T going to all of these different stations, all these different channels. So this is not a function. X equals 2. If we were to graph this, we would go over to 2 on the X line and then make a line right here. So this obviously does not pass the vertical line test, and it has an undefined slope. So no, this is not a function. And this, just a regular old function. Alright, determine whether each is a function. So it looks like all of our x's are different, so yes. Right here, our 4's are repeating and they go to 2 different numbers. So, no. Going back to this one, we have some y's that repeat, but that is okay. We're just looking at the x's to see if the x's repeat. Right here we've got two x's that are the same going to two different numbers, so no. Right here, this is a function. It's okay if our y's repeat. We can have the same output, but these are two different numbers going to this y, and that is completely okay. Alright, on this one, our y's are repeating. That's fine. However, we have a 5 right here for x and a 5 right here repeating, going to different outputs, so no. This one, all of our x's are different, so yes, this is a function. This one, our x's are different, so yes. This one, our x goes to 3 different outputs, so this is not a function. This is just talking about our vertical line test, which we have already gone over. Determine whether each graph represents a function. We can already see right here that this does not pass the vertical line test because we go through 2 different points. So nope, this is not a function. This one passes the vertical line test. So yes. This one passes the vertical line test, so it is a function. This one also passes the vertical line test. This circle right here is going through 2 points at the same time. So no, it is not a function. And this one does indeed pass the vertical line test. Alright, there you go. Identifying functions.